This time I'll be choosing a reference code written from other people that can improve your state handling inside of React. So the first case for discussion is that we have several useState statements in our application, and let's say here we have two states and the third one depends on the first and the second, and this might create a problem. The solution usually is to remove the third useState, and here is the code. Actually, it comes from Johannes Ketman, and this is the case of redundant state. Here we have an input box with name and surname, and we're composing the full name out of it. For three of them, we're using useState, and basically this might create problems. So the solution is just to compose directly the computed value full name without using the useState, and it's quite simple. For the example 2, actually we have the case of duplicate state, where we are having props that we are passing to the component, and then we are tracking a selected item with useState. If we have external source of data and it updates this array of items, we will not be able to reflect the changes because we will be still referencing the old data. So here in the example, we are having a list of items and we're opening a model to show those items. The thing is that if we make changes to the items or create an HTTP request and then close the model, they will not be reflected. Okay, so here the problem is that the moment we click on an item, we're passing to the model the whole item information, and if this information changes from outside, the items prop here will be changed, but it will not reflect the clicked item, so we will still be pointing to the old information. And of course we can fix this by tracking and synchronizing the selected item using useEffect, so the moment the items are changing, also the selected item can change. But the simple way is just, instead of tracking the whole item, to track with the useState its ID. And then when we are having a changed ID, we can actually find which item we are trying to select based on this ID. And this way we'll have no problems in the synchronization between the data which is inside of the model and inside of the main component. In this example, updating state via useEffect, we are trying inside of the useEffect to use the set selected item to update the state. Again, this complicates the code. Of course, you can read the full description of the problem. The solution is once again to just track the item ID and not use useEffect in this case. Another example of the pitfalls of useEffect, where we're trying to listen for changes that occur in our state variable, and based on those changes to run additional code. So here we are running a logging event based on certain variable that is saved in the state. And again, this disturbs the logic and creates other problems. The solution is quite simple. Basically, instead of useEffect, we are packing everything inside of the trigger function, which is toggle details here. So the moment we are clicking on the button, we are not only modifying the state, but also running our side effect function. And here is the schematic. Instead, in the first case, to have an useState, and then the useEffect to listen for a change and to run our function, which makes three operations. We are just placing all of our information inside of the triggering function, and this solves this problem. Then we have contradicting state, where the example is for fetching some data, where we are setting different flags for loading, for error, and we are setting the data, and this can create a lot of combinations between those three variables. And in order to simplify the logic, we can use reducer, where clearly we can dispatch certain actions, types, and data that we would like to respond to, and then handle them in one switch case, which makes the logic clearer and reduces the possible combinations and thus the mistakes that we can make. Alright, the next examples are for the improvement of rendering of React applications. So this is the case of useRef. This is from Yogesh Chavan. Here in the example, we are having one counter and one button. When we click on the button, we are supposed to increase one internal variable, which is not rendered from React. But nevertheless, this creates performance issue because it re-renders the whole component. In such cases, we can use useRef and track the data instead of useState. And this way, we are saving a lot of renderings. And as you can see here in the console log, we still have the increase of the counter. The next two examples are for keeping the state closer to the component or to extract the state into a mini component where needed. And examples are from Sahil Khokhar. Basically, we are trying to isolate just the parts of the component that we would like to use our state and to put the state variable there in order to re-render as less as possible data. This means moving the state down. And here, as you can see, we have our application with one counter. The counter component itself, we separate it in two components. One which will calculate something that takes time and doesn't need to be re-rendered. And the other one is something that depends on the state. So by separating this way the application, it functions absolutely the same way, but React will not recalculate the expensive component, and this way we'll be saving a lot of time for our application. Of course, there are cases where this is not possible to cut down the component. Such case can be seen in the blog of Dan Abramov, where we have one parent component that passes the state, here the color, to our component, but at the same time we are having an expensive component nested inside of the parent component. So basically here we cannot separate and extract the expensive tree because it's a child of the parent component. And in this case the solutions is very interesting. We are wrapping the whole application with our state dependent component called color picker, and we're performing our actions. As you can see, we are returning a div which depends on the color and an input value. And then we're using the children property that will render everything else inside of this color picker. And by using this property, React will see that there are no changes in the expensive tree, and all the changes that need to be re-rendered will be inside of the div and the input. This way optimizing again the performance of the application.